Hi, welcome to our math. Today I'm doing a series of videos on inequalities and rationals. In this video, I want to solve this problem, and it says leave my answer in interval notation. To solve this problem, I can't cross multiply. That is not an option. As much as you might want to cross multiply, that can't happen. You have to set this inequality equal to 0, combine into one large fraction, and test your intervals. It's the only way. So I'm going to subtract this fraction over. So I have 2x plus 7 minus 1x minus 5. Now, to get a least common denominator, it's going to be this x plus 7 and this x minus 5. So I need to multiply the x minus 5 to numerator and denominator here. So I have 2x minus 5 times x plus 7, x minus 5. Minus, I need to multiply the x plus 7 to numerator and denominator here. 1 times x plus 7 times x plus 7x minus 5. All right, now they both have the same denominator. I can now combine them into one fraction, and all of this is greater than or equal to 0. Because this is subtraction, I'm going to say plus and make the one that I'm multiplying to this fraction a negative. So when I distribute it in, both the x and the 7 get treated with this -1. If I don't do that, if you don't do that, there is a very good chance the x will get to be negative, but the 7 will stay positive. So changing this to a plus and making this a negative and distributing your negative is a very smart move. All right, I'm going to distribute the 2 here and get 2x minus 10. Distribute the -1 there and get minus x minus 7. This is all over x plus 7, x minus 5, and it is greater than or equal to 0. When I combine my like terms, 2x minus x is x, -10 minus 7 is minus 17, and believe it or not, we are done. There's no reducing. Every variable has its own parenthesis, and there are no exponents, so we are done. We need to collect our zeros. The x minus 17 is 0 when x is 17. The x plus 7 is 0 when x is -7. And the x minus 5 is 0 when x is 5. Now, what I need to do next is I need to test my intervals. And what I mean by that is if I make a number line from -infinity to +infinity, and I put these numbers down. Now, my smallest number is -7. Next, I have my 5. Next, I have my 17. Notice I'm not trying to write this at all to scale. I'm just putting my number. It's actually not too bad for scale, but I'm not trying. I'm just putting 3 numbers down. If I were to graph this, however it graphs, the graph is only going to cross, this is equivalent to my x-axis, is only going to cross at these 3 points. So that means the graph is completely negative or positive between the points. It's not going to cross again. So if it's negative at one point in this interval, it is negative at all points in this interval. So I'm going to choose a point. For instance, I could choose -10, and I'm going to test it. And the way I test it is I'm going to test it with these 3. This is going to be my key to testing. -10 minus 17 is a very negative number. Now, I don't care what it actually is. I just want to know if it's negative or positive. -10 plus 7 is also negative. -10 minus 5, negative. Now, 3 negatives, negative times a negative is positive, and negative divided by a positive, this is negative. Because -10 yields a negative answer, everything in this entire interval is going to be negative. I'm next going to test 0. 0 is easy. 0 minus 17, negative. 0 plus 7, positive. 0 minus 5, negative. Negative divided by negative is positive. Positive, positive. This is all positive. So this interval is positive. Next interval, we will take 10. 10 minus 17 is negative. Positive. And 10 minus 5 is positive. Well, the denominator is positive, but that negative up top is going to make the whole thing negative. And then we'll come over here. Let's do like x equals 50. 50 minus 17 is positive. $50 plus 7 is positive. And 50 minus 5 is positive. Well, everything is positive. We want, according to this, positive. We want it to be bigger than, greater than or equal to, so bigger than 0. So we want the positive. So we want the negative 7 to 5 joined with the 17 to positive infinity. Now, I haven't put in my brackets or parentheses yet. That is because I want to make sure I get them correct. The negative 7 and the 5 are both in the denominator of a fraction. And you can never have a 0 in the denominator of a fraction, so we can't equal either of those. So both the negative 7 and the 5 have to have parentheses because we cannot equal them. But because this inequality has an equal sign, we can equal the 17. So we will put a bracket at the 17 because we can equal that. So the denominator we cannot equal, it is outside of the domain. But the numerator we can equal because we can equal 0. So one bracket in this whole kit and caboodle. I hope you've enjoyed this video. Please subscribe to my YouTube channel. And I will see you on the next video. Thanks.